In this video, we're going to use information that we've already learned about the properties of parallelograms and other important definitions and information that we know in order to prove this thing here. So what we have here is that ABDG is a parallelogram, and that's given information. And we also know that AF is congruent to CF. So here we go. ABDG, this shape here is a parallelogram. And we also know, again, that AF, CF, so AF and CF are congruent to each other. All right, so we're going to go ahead and we're going to prove that angle BDG, which is right here, is congruent to angle C, which is right here. All right, so we can start off with something that is given and then work our way forward. So we know, again, that ABDG is a parallelogram, and I write it this way for short. And the reason we know that is because it is given. All right, so we're off to a fantastic start. All right, so the next thing that I want to show is that angle BDG right here, is congruent to angle A. And we know that because of the properties of parallelograms that we've recently learned, that opposite angles in a parallelogram are always congruent. So let's write that down. Angle BDG is going to be congruent to angle A. And again, we know that because the opposite angles, so we'll write it down for short, opposite angles of a parallelogram are congruent. And as you can see, I'm writing the shortcut here, and you can do that too as long as it's clear. All right, so we're going to actually mark those in so we remember that we've done that. So those two angles are congruent to each other. All right. The next thing that we can put down here is that, well, we do have more given information, so we can put that given information down. So we know that AF right here, oops, right here is congruent to CF right here. So it's actually isosceles triangle, which we'll get to in just a moment. So AF is going to be congruent to CF. And the reason we know that, I love this reason, it's always the easiest one, they gave it to us, it was given. All right, so as I just said, since that and that are congruent, then we know that this angle right here, and I'm just going to use that single blue, is congruent to that. And we know that because of the definition of an isosceles triangle, or the isosceles triangle theorem. So we can write that down, that angle A is congruent to angle C. And that's because it is an isosceles triangle. Oops. I love that word. It's so wonderfully easy to spell. Just kidding. All right. So here we have an isosceles triangle, and that again is the reason why that and that are congruent to each other. Okay, so finally, if A was congruent to D right here, or I should say BDG right here, and A is also congruent to C, we can substitute one into the other and say that BDG right here has to then be congruent to C. And that's what we were being asked to prove, so we got it. So let's write that down and then we're done. So we have here that BDG is congruent to angle C. And we know that because of the substitution we did. The reason here could either be substitution or transitive property. It's okay either way. All right. So there we have it. That is the proof as to why angle BDG is congruent to angle C.